Hello friends, today we will see the short trick to find the number of times a sequence is detected from a given bit stream. In the previous video, we have seen how to draw the state diagram for a given sequence. And now in this video, we will first study how to get the sequence from the state diagram, and then we will study to count the number of times that sequence is repeated in a given bit stream. Okay, so starting with the video. So we will see the concept from the sum directly. So the first sum is the state diagram of a sequence detector is shown below. State S0 is the initial state of the sequence detector, and if the output is 1, then what was the sequence that has been detected? This is the GATE 2020 EC sum, and the question is the state diagram is given and we need to find the sequence for which the output is 1. Okay, so for this type of question, first we need to find transition for which the output is 1. Here you will say this is the input and this is the output. So you can say that for this transition we get the output as 1. So we will find a path to this transition such that the output will be 1. So here you can see the path will be from S0. Here you can see the state is already given, that is S0. Okay, so we will start from S0 and we will trace till we get this transition. Okay, so the transition will be from S0 to S1 to S2 to S3 to S4 and then again to S3. So the bit for which we get this path is 0, 1, 0, 1 and 0. Okay, so you can say that for the sequence 0, 1, 0, 1, 0, the output will be 1. So you have successfully detected the sequence for which this state diagram give output as 1. Okay, till now we have learned how to extract this sequence from a given state diagram, and now we will study how to count the number of times the sequence has been detected from a given bit stream. Okay, so so to start with that, we will see this question. The question is the state diagram of a finite state machine designed to detect an overlapping of 3 bits as shown in figure. The finite state machine have an input as in and the output as out. The critical state of the finite state machine is S0, basically the initial state. And if the input sequence is this, basically this is a bit stream with the leftmost bit as the starting bit, that is 1, then the number of times out will be 1. So basically what this question is saying is that you have given with this state diagram and with this bit stream, you have to count the number of times this state diagram will give 1 for a given bit stream. Okay, so first we will see the traditional way to solve this. So we will follow this state diagram for this given bit stream. Okay, so initial state is S0, right? So S0, when the input is 1, then we will switch to S1. Here you can see the input is 1, we will switch to S1. Okay, now the input is 0. So from S1, if the input is 0, then we will go to S2. Okay, now at S2, if the input is 1, then we will go to S3. Saying that output is 1. You can see here the output is 1 for the given input 1. At S2, if the input is 1, you get the output as 1 and you will switch to S3. Okay. Now at S3, if the input is 0, then we will switch to S2 again. Output is 0. Okay, now at S2, if the input is 1, then we will switch to S3. Okay, here it was 0 and here it is 1, saying that output will be 1 at this transition. Now at S3, we get the input as 1, so we will switch to S1. Okay, input is 1, output will be 0. Now at S1, you get the input as 1. So for 1 as an input, you will remain as S1 state. Okay, now at S1, if you get the input as 0, then you will switch to S2. Okay, the input was 0. Now at S2, if you get the input as 1, then you will switch to S3, saying that the output is 1. Okay. Now at S3, if the input is 0, then you will switch to S2, saying that output is 0 and for the input as 0. Okay. Now at S2 again, if the input is 0, then you will switch to S0. Input was 0. Now from S0, if the input is 1, then you will switch to S1. Okay, input is 1. Now at S1, if the input is 1, then you will remain at that state. Okay. Now at S1, if the input is 0, then you will switch to S2. Okay, saying that input was 0. Now at S2, if the input is 1, then you will switch to S3, saying that input is 1 and the output was 1. So now you can count for the number of times you get the output as 1 is 1, 2, 3, 4. So you can say the output is 1 for 4 number of times. Basically what it means is the sequence is detected 4 number of times by giving the output as 1. Okay, now we will see the trick. So for the trick, the rule is, first you need to find the sequence for which you will get the output as 1. Okay, so first find the sequence, then check whether in the question the finite state machine is with the condition overlapping or it is with non-overlapping condition. So we will find the overlapping or non-overlapping. Then according to this, we will count how many times this sequence is repeated in the given bit stream. Okay, so now we will start the trick. So first we need to find the sequence. Okay, so the sequence for which the output is 1 is 1, 0, 1. Okay, so the sequence is 1, 0, 1. Now we will find how many times this 1, 0, 1 is repeated in the given bit stream. So the bit stream is given as 1, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1. In this sequence you get 1, 0, 1 here, here. Since the overlapping is allowed, so this one can be reused. Okay, then here, then here. So you can say this 101 sequence is repeated 4 times in the given bit string. So basically you can say this state diagram will give output as 1 4 times if the input bit stream is this. So here you can see the amount of time this trick can reduce to solve this type of question. Okay, so that's it for today. Thank you guys.